All right, everybody, so we're going to go through how to write a rationale. A rationale is the second part, usually, of your student experiment that you should be writing. So at this point, you should have already looked into the experiment and you know how you're going to modify your experiment. You should have chosen something that you're interested in modifying, and then you need to have analysed your experiment to determine problems, errors, or interesting observations. You're trying to think, how could you make this more precise, how more accurate, things like that. Now you need to research the theory related to the problems, errors, and interesting observations that you have identified. That's the point of the rationale. And then you will need to justify your modifications with scientific reasoning. So you could be thinking that there wasn't very many trials. Well, you need to find some sort of scientific reasoning that you can reference to that says more trials are better. Is there something that, and it's popular knowledge, but you need to have something that you can reference to. Is there something that you can reference to that says the smaller the measurement sizes that you're taking, the better? Stuff like that. Now, you need to be able to collect sufficient and valid data in the time that you've got available. So if you have designed this experiment or you've decided to change an experiment, but you won't be able to collect sufficient data, sufficient meaning enough that you could actually identify trends that occur, then you haven't actually designed the experiment properly. So your research, this is my ideas of how you could be researching. So you could use an inquiry grid where you've got your topics at the top, you've got your lists of sources that you're using, and then you're writing notes into it. This is what you then look at to then write your rationale. You're not looking at the web pages. This one over here, this is called Cornell note taking. So you have notes that you take from the web page. Recall column could be things like keywords, definitions, things like that. And then down the bottom, you've got the summary of everything that this notes column has said. So in summary, a couple of lines, this is what all of it's saying. Then you could also be using your in-text reference. This would have your actual reference that will go in your reference list, and then notes written in dot point format. Make sure you're not writing in sentences because that's not how you take notes. You write in dot point format. If you're writing in sentences, then you're more than likely going to plagiarize. So you shouldn't be looking at a website and then typing straight into your rationale. That puts you at major risk of plagiarism. So just to remind you, it's to take one and use one's own thoughts or to copy someone else's ideas improperly, and it's an act of fraud. Okay? 10 types of plagiarism. I've just popped this in here just so that you're aware of the different things that we'll look at. Sorry, I'll put myself over here. We've got things like you've paraphrased various sources. You are basically giving word for word what someone else has said. This is properly quoted, but you've quoted too much. This is just control copied straight from it. It's also plagiarism if you don't reference properly. So if you've used something and you haven't referenced properly, then it's plagiarism. All right, so your rationale. These are the scaffolding that we've given you. So things like identify the aim of the experiment and explain why this led to the new idea for the experiment. These here are your cognitive verbs. That's very important when we're looking at how you're actually going to respond to these scaffolding. Identify is very brief. Explain, you need more detail. Justify means you need to give reasoning because of. Why? Why did you do that? So here we've got the question format scaffolding, so you can see that they link up. Okay, ideally, this means that there's 4 sections of your rationale that we're looking for. This one's talking about the original experiment and why it led to the new experiment. That's where you're looking at what actually did you see was not accurate, or what are you improving, what didn't do well. Here we're looking at the related subject matter researching. So that's a scientific theory. The aim of the new experiment, it doesn't need to be very, very detailed. It's just concisely stating it. And then here is your hypothesis or your prediction of what will happen. Some examples. So here's some sentence starters that I've used. So the original experiment tested how a lodia plant responded to the varied light intensities by using blah, 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 blah. That's what my original experiment was. It was noticed that inaccurate measurements were being taken due to blah, 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 blah. This led to the new method using whatever I'm going to change. The aim of the new experiment is to I have moved these around from the previous scaffolding just because in my head it flowed better. All right. Here I'm talking about the subject matter. Photosynthesis is factors that affect photosynthesis are concentration of sodium bicarbonate water produces what? Carbon dioxide. So then the water plant can photosynthesize or whatever you're going on about. Okay. Then it is more than okay for you to use the typical if, then, because. So it is hypothesized that when, whatever you're increasing or decreasing, don't just say changes. You need to be specific because in your analysis and your conclusion, you are responding to this hypothesis. So if you say, yes, it changed, then that's not specific. That's not you showing that you actually know what you're talking about, okay? So you need to actually identify what you think is going to happen if you do something specific. If I increase this, then this will increase as well, okay? And then you need to say because, why? Don't just say if you change something, something will change. Oh, really? Okay, this is how is it marked. So for ours, we have our IS and G, and there's a criteria called research and planning. So you can see on the side, there's marks here. It's 5 to 6 or 3 to 4. When you're looking at this, there's different sections of this. So I'm going to focus mostly on the 5 to 6 because that's what you should be focusing for. Then you also have your communication that's marked all throughout the essay. Okay, so your rationale, a considered rationale. You need to have a well thought about rationale. All scientific theory and concepts are linked to the experiment topic and explained concisely. Remember, you have a word count. You cannot go over the word count. If you go over the word count, we stop reading. So if you reach 1,500 to 2,000 words and I've only got to your analysis, that's all I'm reading. I'm not going to read your conclusion and that will not work towards your mark. So you need to be really, really consistent and concise so that you do not go over your word count.